Hey guys, in today's video I'll be teaching you how to approximate values for roots of an equation using the iterative method. This is part of the Numerical Methods chapter. I already have one video on locating roots and there'll be another one coming soon on the Newton-Raphson method. So, iteration is a method of approximating roots to an equation by using an iterative formula to incrementally improve the approximation of a root. Note how here at the top it says an iterative formula and not the iterative formula. There is no specific formula, you just work it out with every question that you get given. Here I've got this question. We want to approximate a root for this function, so we do that by getting x on one side of the equation and then everything else on the other side of the equation. So because we're approximating roots, we need it to be equal to 0, and then we just want to rearrange it so we have x on one side. There are different ways you can do this, which is why there are multiple iterative formulas for each function. However, we're going to do it this way. We're going to take the 5x and the 3 and put it on the other side of the equation. And then we're going to square root the whole thing just to get x on one side. And that is our iterative formula for this function. And so what we're going to do is we're going to put in the value for x on this side, and whatever our answer is here, we'll be putting that back in again, and then whatever answer we get again, we'll put it back. And we keep repeating that process until we eventually converge on, hopefully, a root. So here I have two diagrams representing how this works. We put in a value for x, and it bounces off what would be the right side of the equation onto this line here, y equals x, which would be the left side of the equation. And then we take that value for x and we put that back in, and then it bounces off and gives us another value for x, and we get closer and closer to the point where they converge. There are two different ways this can happen. We can have it in a staircase diagram like this, or in a cobweb diagram like this. But either way, they're both converging on a root. However, it doesn't always work. Sometimes if you start with the wrong value, you might end up diverging from the root. So for example here, we've got this one where, because we started this side, it's just going to keep getting further and further away from the root. Whereas if we started here, it would get closer and closer. So back to this question. We're going to write this formula here like so. Xn add 1 is equal to root 5xn add 3. And that's because we're going to put in a value here, and our answer will be the next value that we put in. And that's why in the question we've been given this x0 equals 5, because that's the value we're going to start with. So take your calculator and press 5 and then press equals, and now that will be stored in your answer memory. So then we're going to put in this bit of the equation, root 5 answer add 3, and this answer here will be 5 for the first one, and then when we press equals it'll be this, and then we press equals again, it'll be the next answer and the next answer. And what we're going to do is we're going to work out x1, x2 and x3. So x1, as we'd already worked out, is 2 root 7, and we press equals again and we get x2, and we press equals again and we get x3. And every time we press it, we get closer and closer to the answer. So if we press this loads of times, they'll eventually reach a point where it's becoming so accurate that our calculators can't make it any more accurate. However, usually in these sorts of questions you're only asked to go up to x3. So our answer for this will be x3 is roughly equal to 5.49. That's to three significant figures. So here we have another one which has this function 3 cos of x squared add x minus 2, and we want to find the iterative formula and then use x0 equals 1 to find x1, x2 and x3. So first we want to make x the subject of the equation. 3 cos of x squared add x minus 2 equals 0, and then we're going to go cos of x squared equals 2 minus x over 3. I've just done that all in one step. And then we're going to use arc cos to get rid of this, and then square root the whole thing to get x. And that is our iterative formula. So then we want to use x0 equals 1 to work out the next three values. Once again, take your calculator, press the 1 and then press equals, and now that's in our answer memory. And then it's just a matter of typing it all into your calculator with answer instead of x. And the answer there is x1, 1.10948. Press it again, that's x2. And press it again and we get x3. So that's that part of the question done. But then the second half says show that alpha equals 1.1298 is correct to 4 decimal places, and that just goes back to our last video on locating roots. So we want to take 1.1298 and find its upper and lower bounds because it's correct to 4 decimal places. So the lower bound will be 1.12975 because that will round up, and the upper bound is 1.12985 because anything below that will round down. And then we want to put both of those back into the original function up here, f of 1.12975, and then just type that into your calculator. So we get 0.0004230, etc, etc. And then we want to do f of 1.12985 now. press equals, and we get an answer of negative 0.000125569, etc., etc. And all you want to say is that here this answer is greater than 0 and this answer is less than 0, which means there's been a sign change, and therefore alpha equals 1.1298 is correct to 4 decimal places. Right, so that was the iterative method. The next and final video on this chapter will be the Newton-Raphson method. So if you found this video helpful, leave a like. Any topics you want me to cover in future, leave a comment down below, and subscribe for more maths related videos.